Hello.
Hello.
All right, guys, you need 2.10 notes for today. We're going to get rolling here in a second because we have a little bit full day of notes. So 2.10, factoring using synthetic division, factor theorem. All right, kind of a little bit of a reminder. Today we're doing 2.10. That is the last section in Unit 2. So the last section in our factoring unit that we're doing. As I've told you before, that doesn't mean that we're done factoring after we do that. All right, we really are factoring for the next probably 4 units. So everything we've done in this unit is kind of the most important thing that you have moving forward into the next unit. So you really need to make sure that you're understanding this so that you can use this as we're moving forward. So today we're going to finish 210. Tonight's homework is going to be 210 and the 2.9, 210 quiz. Okay, so it'll be your 210 homework and then also that quiz for that. And then tomorrow we'll review. And then Friday is your Unit 2 test. Okay, which is add, subtract, multiply, divide, and then basically factoring all these different ways. So what we're going to do today is we're going to continue factoring. And so I talked to you about how when we have 2 terms, we're using difference of squares or we're using sum of difference of cubes. I talked about if we have 3 terms, that's where we're using the X method. We talked about if we have 4 terms, we're grouping. What we're going to talk about today is if we have 4 or more terms, what we can do. All right, so we briefly talked about it when we talked about grouping, that if when we group, the terms don't match up, or like you can't group it, you can't solve it that way, you can't factor it that way. What we're going to talk about today is if we can't group it, what do we do? All right, and so we're going to go back to synthetic division is what we're going to talk more about today, which we talked about earlier in the unit, and talk about how we can use division to then break these polynomials up, okay, and to factor them. So real quick, first thing I want to do is just review synthetic division. All right, so remember synthetic division is just kind of a shortcut for dividing. So if I want to divide a polynomial by another polynomial, or more specifically a binomial. So if I want to take 2x cubed plus 6x squared plus 29 and divide it by x plus 4, remember this, the way that we figure out what we use is we set this equal to 0, which is always going to change the sign. So I put that -4 here. We put all of our coefficients and constant in here without the variables. Remember, right here we're missing an x, so we have to put that 0 in to represent that x. Okay, so I put my 2 here, my 6 here, my 0 here, and my 29 here. And then remember, it's just a process. Bring down, multiply, add, and continue to multiply, add until you get to the end. So we bring down the 2, multiply, negative 4 times 2 is negative 8, add. Multiply, positive 8, add. Multiply, get negative 32, add those together, that gives us a remainder of negative 3. All right, and then remember when we're writing our answer, this is our remainder, this is our constant, or just the number, this becomes our x, this becomes our x squared, if we had more, it'd be x cubed, and so on. Okay, so here's what we're going to talk about today. If you look at this example right here, would x plus 4 be a factor of that polynomial? No. Okay, if I say, is 3 a factor of 20? The way you'd figure that out is you take 20 divided by 3 and see if it goes into it evenly. The answer is no. There's a remainder. Same thing with polynomials. The way that I figure out if x plus 4 is a factor of this polynomial is I divide it, synthetic division, and see if there's a remainder. If there's a remainder, then no, it's not a factor. If the remainder is 0, then yes, it divides into it evenly and it is a factor. Okay, so that's exactly what we're going to do today. We're going to use synthetic division to figure out factors, to figure out if something is a factor of a polynomial. Okay, and this is just really wordy. Don't try to memorize or anything that here, but that's exactly what this says. What I just explained to you, that's what this says. So the binomial x minus a is a factor of the polynomial f of x if and only if f of a equals 0. What that's saying is that this right here is a factor of some polynomial. We're calling that polynomial f of x. If the remainder is 0. Okay, that's what it's saying. It's saying this is a factor of the polynomial if the remainder is 0. And that's exactly what the words over here say. They say when a polynomial is divided by one of its binomial factors, the quotient is called a depressed polynomial. Don't really have to worry about that. If the remainder is 0, okay, that means that f of that number equals 0. It also means the divisor resulting in remaining of 0 is a factor of the polynomial. Again, that's just saying it is a factor if the remainder is 0. Again, that's the same thing that we do when we talk about numbers. If I said, is 4 a factor of 15? You take 15 divided by 4, gives you a decimal, answer's no. If I say, is 7 a factor of 14? 14 divided by 7 is 2, remainder is 0. So yes, 7 is a factor of 14. Okay, we're doing the exact same thing, we're just doing it with polynomials and binomials here instead of just numbers. So another example before we actually jump into doing some examples here. If we wanted to divide this polynomial right here by x minus 3, that would tell us if x minus 3 is a factor. So we put positive 3 here, we use our synthetic division, we get a remainder of 0. What that tells us right here, since the remainder is 0, x minus 3 is a factor of this. Okay, and so what we're going to end up doing then is we're going to continue factoring from there. We're going to take this, what we get after we pull out that x minus 3, and continue factoring if we can. Let's do an example. So it says factor this polynomial, f of x, completely. Okay, completely break it down into as many factors as we possibly can. All right. Given that x plus 3 is a factor. So they're telling us x plus 3 is a factor, meaning when I use synthetic division here with x plus 3, what should my remainder be? 0. Okay, if you use x plus 3 in synthetic division here and you get a remainder anything other than 0, you did it wrong. Okay, because it's telling you that the remainder has to be 0 by telling you that it's a factor. So that's where we're going to start. We're going to start with our synthetic division. So I'm going to put 1 here, 6 here, 11, 6. Remember, it's going to end up being opposite sign. So I put my -3 over here. Bring down, multiply, add. Multiply, add, multiply, add. So this is my remainder. This is my number, constant. This is my x. This is my x squared. So that leaves me with x squared plus 3x plus 2. Now, we don't want to change the original problem. We're just factoring it. We're breaking it down. So we also have to remember that x plus 3 is also a factor. So what I'm going to do, I have to leave that x plus 3, that factor that we already pulled out front, because that's also a factor. Okay, because we know that x plus 3 times what we got left equals this original polynomial up here. Now, it told us to factor completely. Can I factor x squared plus 3x plus 2? Let's try. Let's use the x method. A, C, B down here, A. Can I multiply into 2, add into 3? Yep, 2 and 1. So that tells me this x squared plus 3x plus 2 factors into x plus 2, x plus 1. And then don't forget to bring down this original that they told us, x plus 3. All right, so what that means, if I would multiply all 3 of these back together, it would give me our original polynomial. Okay, remember, factors are things that can be multiplied together to get whatever we're talking about. Questions? All right, let's do another one of those real quick. Okay, so again, they give us this factor right here. Okay, they tell us that x plus 5 can be multiplied into this. So let's start with synthetic division. Remember, if you're missing a number, you have to put a placeholder there. Here we don't, so we're good. So my factor is x plus 5, so that means -5 is going over here. Bring down, multiply, add. Multiply, add. Multiply, add. Multiply, add. Multiply, add. Again, they told us it was a factor, so we already knew the remainder had to be 0. So here's my number. Here's my x squared, x cubed, x to the 4th. Do I need to write 0x squared? No. Okay, so that leaves me with x to the fourth minus 2x cubed plus x minus 2. And then I still have this x plus 5 at the front that they told us is a factor. Now I have 4 terms. Anytime I have 4 terms, what do we try?
Grouping.
Grouping. Okay, so that's exactly what I'm going to do here. I'm going to group first 2, last 2. So I'm going to take out an x cubed here. Leaves me with x minus 2. Can I take anything out of this x minus 2? No, I'm going to put a 1 here just so I see that as a placeholder. Okay, it'll help you kind of forget to put that 1 in. So I'm going to pull out just a positive 1, which is basically nothing. But I'm going to put it there just so I can see what's going on. So that leaves me with x minus 2 times x cubed plus 1. And then I still have my x plus 5 at the beginning. Now, 2 terms, binomials. That's a linear. I'm done. That's a linear. I'm done. Anytime I have cubed, I'm looking for sum or difference of cubes. Is this a sum or difference of cubes? Is x cubed a perfect cube? Is 1 a perfect cube? This can be factored a little bit further. Okay, so this is where a is x, b is 1, and we're factoring it into ab, a squared, ab, b squared. So leave my x plus 5 alone, leave my x minus 2 alone, and then we're going to factor this. So x, 1, x squared, x, 1, and then put my signs in. So SOAP, same as the original, opposite of the original, always positive. And that is my final answer. Okay, we're really putting everything together. All the different factoring that we've done, it's really starting to come together, and we're doing it all in layers here. Okay, so that's if I give you a factor. If I give you a factor, you can divide it out using synthetic division, and then we're just breaking it down as far as we can possibly go. Okay, the second thing we're going to look at, I think I have it here, is, and we're not going to actually do these, so I was going to try covering it up. Okay, the second thing we're going to do here is, what if I don't give you a factor? All right, so what if I tell you to factor a polynomial? It's not 2 terms, it's not 3 terms, you're not able to group it. Okay, so what if we can't do all of those methods that we've talked about, and I don't give you a factor? I don't give you something that you can just go straight and do synthetic division and divide it out. What we're going to have to do is we're going to have to find possible factors. Okay, we're going to have to find things that we can try and see if they're a factor so that we can divide and see. Just like when I tell you, what are the factors of 120? You might know those. You might just have to start dividing numbers. You might divide 2, you might divide 3, you might divide 4, you might divide 5, and just see which one gives you a remainder of 0. We're going to do the exact same thing. We're going to use synthetic division to try possible numbers and see which ones work. Okay, see which ones gives us a remainder of 0. And so here's what we're going to do. Okay, now we don't want an infinite number of things to try, right? I don't want to have to plug in 1/2 and 1/5 and 2/3 and -1 and -30 and +15. I don't want to have to plug in a bunch of random numbers. I want to narrow down my possibilities. And so what we have is this thing called P's over Q's. okay? P's over Q's. And what this gives us is possible numbers to try. Okay, so this is going to give us what numbers should we try using with synthetic division that might work. Now, they're not all going to work, but we want to narrow it down from an infinite number of numbers to maybe 8 that we need to try. Okay, and so we're going to use this thing called P's over Q's. And so what this is, P is the factors of the constant term. Okay, this right here is kind of the little shortcut, easy terms that I like to use. P represents the factors of the last term, which is our constant. Q is the factors of the first term. Okay, here it says a sub 1. It's our first term. So it's factors of the last term over factors of the first term. Okay, so let's look at this. So what we're looking at here, we're doing P's over Q's to tell us what to try. So factors of the last term would be 1, 2, 4, 5, 10, and 20. Now, all those numbers can be positive or negative, correct? Because I could take -1 times -20 to get 20. Or I could take +1 times +20 and get 20. So all of these numbers are actually going to be +1, -1, +2, -2. Factors of the first term is simply just 1 times 1. And so my P's over Q's here are positive or negative 1, 2, 4, 5, 10, and 20 over positive or negative 1. Well, we should know anything over 1 is just that number, right? And so our P's over Q's become just positive or negative 1, 2, 4, 5, 10, and 20. Now, at this point, those P's over Q's probably mean nothing to you. But what that is, those are the numbers we're going to try in our synthetic division. Okay, so when I look at this, I don't have to try 3. I know 3 isn't a possibility here. Okay, so those are the only numbers that we'll have to try when we're using synthetic division to try figuring out what numbers to use. Second one here. Factors of the last term. 1, 2, 3, 6. Again, those are all positive or negative. Factors of the first term. 1, 2. Again, positive or negative. So remember, P's over Q's are the last numbers. It's kind of opposite of what you would think. Last numbers go first on top. First numbers go on bottom. Okay, so I have positive 1, 2, 3, 6 over positive or negative 1, 2. Now we're going to take all of those and simplify them. So I'm going to put 1 over everything. So I'm going to say 1 over 1, which is just 1, and 1 over 2, which gives me 1/2. Then I'm going to put 2 over both of them. 2 over 1 is just 2. 2 over 2, what's 2 over 2 give me? Do I already have that? Don't have to write it again. Okay, 2 over 2 is just 1. Well, I don't have to write that again. I already have 1 as a possible answer right here. Now 3. 3 over 1. 3 over 2. Now 6. 6 over 1. 6 over 2 is 3. I already have 3 there. Those are my possible answers. So again, yes, that might seem like a lot, right? We have 12 different possibilities here. 1, 2, 3, 4, 5, 6, and then they're all positive or negative. So we have 12 different things that could be answers here. But it's 12 compared to an infinite number before. Okay, now once we start using synthetic division, you're only going to be trying these numbers, so you wouldn't have to try 4 or 5 or 7 or 8 or any of those other numbers. Okay, so now let's look at how we're going to use these. Okay, so we just did this. This is the problem we just did right here. I'm going to copy these. Paste them right here. So we just found out what our P's over Q's are for this problem. Right, so this is the first problem we just did on that last screen. And so the problem says to factor this polynomial completely. Well, we don't have anywhere to start. We don't have anything to try. And so what we're going to do is we're going to use some of these P's over Q's to start out here. Now, look at this hint. I would highly recommend that you try +1 and -1 every time. Okay, I would just start there. It's easier multiplying by 1, right? You get smaller numbers. Start there. And really, you don't need any P's over Q's because every single polynomial will have 1 and -1. Now, if 1 and -1 do not work, then you have to go to the next numbers. But I would always start with 1 and -1. So let's start. Let's find out if 1 is actually a factor here. Okay, so we have 1, -8, 11, 20. Bring down the 1. 1 times 1, -7. -7 is 4. Gives me 4. Remainder of 24. So is 1 a solution here? No. Okay, that tells me that 1 is not a solution. It tells me that x minus 1 is not a factor here. Okay, so now I'm going to just do that process again. This time I'm going to try -1. So 1, -8, 11, 20. Is -1 a solution to this problem? Yes. Okay, yes. And so what that tells me, since it's -1, remember we use the opposite sign for the factor, that tells me that x plus 1 is a factor of this polynomial. Okay, that's what that tells me. And so I didn't have really anywhere to start without my P's over Q's, but then my P's over Q's tell me to try 1 and -1. And so now we're really at the same place that we are on those first problems we did. Okay, on those first problems we did, we now have constant x squared. So I now have x squared minus 9x plus 20. And then I have this factor that I just found of x plus 1. And then I just have to keep going. Okay, just factor the rest of the way. So now I'm going to factor this right here. So I'm going to use my x method. A times c goes up here, so 20. B goes down here, so I want to multiply into 20, add into -9. So that should be 5, -5, and -4. So leave my x plus 1 out front. I have x minus 5, x minus 4. That's my final answer. Okay, so the only difference between these problems and problems we did before, on these we just have to start trying things. If you get a remainder other than 0, it doesn't work. If you get a remainder of 0, then you're kind of in that same place. I would recommend always trying 1 and -1 first. All right, so next one. Notice here, we have 5 terms. Okay, we have 5 terms. There's no other thing that we can do here. Right, we can't group because we have 5 terms. We can't do anything else here. So I'm going to go back to that original problem we did. Because this is the same one. I'm going to pull my P's over Q's over. Okay, so those are my P's over Q's. So now I'm just going to start trying things. Again, you don't have to start with 1 and -1. I would recommend it. If you're like, oh, I know what it has to be, try it. Now, let me point something out. If you have all positive numbers here, so basically if I just keep on adding and multiplying, am I ever going to get to 0? No. So if you ever notice that every single one of these are positive, that's going to tell you that your number is going to have to be negative. Okay, so just kind of a little hint for you when you're guessing numbers. Now here I have this negative at the end. I'm still going to know here that positive 1 is going to be too high. Okay, positive 1 here is never going to get back down to 6 like I need it. So that doesn't work. So start with your next number. Now I'm going to try -1. Does that work? Nope, unfortunately our sign was wrong. As long as I did it correctly. Yep. So that doesn't work either. Now, I would highly recommend not going to the fractions next. That would be the very last thing that I would ever try. So now I'm going to go ahead and try positive or -2, because that's one of my possible solutions. So let's go there. Let's try, I don't care which one, let's try -2. Again, because I have a lot of positive numbers here, I'm going to try a negative before I try a positive. I could be wrong, could be a bad guess. There we go. Okay, so I finally got that remainder, meaning that this -2 is a solution, meaning that the x plus 2, opposite sign, is a factor of this polynomial. So that leaves me with number x squared, x cubed. So 2x cubed minus x squared plus 6x minus 3. And now we have to see if we can continue on. When we have 4 terms, what do we try to do? What do we hope works when we have 4 terms? Grouping. That's exactly what I'm going to try here. You should be able to kind of look at it and see if it's going to group. So if I notice here, this is 2 times bigger than this is 2 times bigger than this. This is a negative, this is a negative. And so when you look at it, you might be able to be like, yeah, that groups. And so you should be able to kind of have an idea. So here I'm going to pull out an x squared. Leaves me with 2x minus 1. Here I'm going to pull out a 3. Leaves me 2x minus 1. So they're the same, so that means I can do grouping. So that leaves me 2x minus 1, x squared plus 3. And I'm going to bring down my x plus 2 at the beginning. So I have a linear, so that's done. I have a linear, so that's done. Here I have a x squared, so I want to look for difference of squares. Is 3 a perfect square? Nope, so I can't factor it. So I'm done. Questions? All right, this last example, very last thing I want to show you. Just kind of a little bit of a reminder. All right, so possibilities here, my P's over Q's here. This is just 1 out front, so it's going to be positive or negative. 1, 2, 3, 5, 6, 10, 15, 30. So really just all of the factors of 30, positive or negative. Again, though, I would, if you're getting stuck on the P's over Q's, just try positive and negative 1 first every single time. Now, the one thing that I wanted to show you here, just to kind of remind you, remember if we're missing a placeholder here, so right here I'm missing an x squared. If you don't put that 0 in when you're doing synthetic division, you will always get it wrong. Okay, so make sure you're putting that in there. Okay, you have to have that in there. So I would try 1. Not going to work. I would try negative 1. I do wrong here. Nothing, I guess. Just ends up being the same thing. Doesn't work. So I'm going to try 2. That works. So that gives me x squared plus 2x minus 15. And then don't forget your factor of x minus 2 at the front because of this here. And then we just finish factoring from there. So use your x method. Negative 15 is up here. 2's down here. What multiplies in negative 15 and adds into 2 should be 5 and negative 3. So this factors into x plus 5, x minus 3. Putting a lot of the factoring together that we've been doing. Questions? Covered quite a bit today. Okay. Homework is 2.10 worksheet. It's not on Delta Math. Your review tomorrow will be on Delta Math, so we'll be getting back to that tomorrow. But for today, your 2.10 worksheet is on a worksheet on Schoology, and then you have your 2.9 to 2.10 quiz that'll be due tomorrow as well. I will go right now and make sure that quiz is enabled so I don't make that mistake again. All right, see you guys tomorrow.